And then we go to the configuration of the STP. Okay, and first we should know the STP have different versions. Okay, the version is what we have discussed is the standard STP. Okay, and there's two another versions, ISTP and MSTP. The ISTP we will discuss later. And by default, the Huawei switch is running the MSTP. Okay, so if you want the switch to running as the standard STP, you should configure this command, STP mode STP. Okay, so of course, when you configure this, all switches in this network, A, B, and C, should all configure this command. So they can be compatible. Okay, they can negotiate each other. Okay, this is the STP mode. Okay, then the STP is running automatically. If you not configure anything, they can still running. Okay, and calculate the STP spanning tree. Okay, and but in the real network, maybe you want to figure out who should be the root, bridge. So how to doing this? Of course, we know that the root bridge is selected by the bridge ID. Okay, bridge ID. Then the bridge ID contains two components. And the first is the priority. The priority default priority value is this value. Okay, 32 kilo. Okay, 32 kilo. And the another value is the MAC address. As we know, the MAC address is bound in the device. You cannot change it. So if you're not doing anything, then the priority value is the same, and then the MAC address, maybe it's randomly. Okay, it's randomly. So the root, where is the root? You cannot decide. Okay, so if you want to decide who is the root, you can change the priority value of the switch. We have also already discussed that the priority value is the step of the priority value is 4 kilo. Okay, so the smallest one is 0, and then the second value is 4 kilo. Okay, the third is 8 kilo. Okay, so here the switch A is 4 kilo. Okay, so this is the smallest value in the all switches. Okay, so switch A will choose at the root bridge. Okay, the configuration I think is simple. Just in the system view mode, and then the STP priority 4 kilo. Okay, that's okay. Then switch A will elected as the root bridge. Okay, and then another, when the other switch, the non-root bridge, calculating the best path to the root, it's depend on the path cost. Okay, depend on RPC, root path cost. Okay, so we need to decide which is the path cost of each link. Okay, of course the default Huawei's device, the default use the .1T standard. If you not change it, yeah, they can run it. Okay, of course if you want to change, you can use this command, STP path cost standard, then choose one. Okay, but I recommended you not to change this. Only when you connect a switch with other manufacturers, you just to confirm which standard is used by this device, and then use the same standard. Okay, and another, of course, the default value is decided by the interface type and the speed of each interface, and then use this standard .1T. Okay, and if you want to change a specified interface cost, then you can get into the interface and then configure this STP cost 2000. Then this interface, the cost of this interface will become 2000. Okay, the manual configuration take privileges than the default cost of this interface. Okay, and then this is another feature, but this feature is not included in the standard STP. Okay, is not included in the standard STP. This feature is included in the RSTP. Okay, RSTP, and this standard we called root protection. What's root protection? Such in this network, the root is switch A. So the switch A will sending the BPDU out. Okay, and if there is an attacker, the hacker, okay, want to destroy your network, okay, or disturb your network, then what he will do? Yeah, he just connect another switch, and then set this switch, the priority value is 0. Okay, this is a better, okay, this is a higher priority than the 4 kilo. Okay, so after this switch is inserted in and then sending out the BPDU, then this switch will erected as the root bridge. So the network topology will totally change. Okay, the blocked link also will be changed. So this is a type of attack. So how to prevent this? You can configure this interface, the root protection. What's root protection? That means the switch C from this interface did not receive a beta BPDU. Okay, if there is a beta BPDU sending from this interface, then the switch C will detect it and then put this interface into a LO state. Okay, this is a method to prevent the attack from the hackers. Okay, and then after the configuration, we can check what's the state of the STP, what's the result of the STP. Okay, so the command is as this: display STP. Okay, then we can see first the mood. We have changed the mood. By default, it's MSTP. Okay, and then the bridge ID. This is the switch A. Okay, this is the BID. The first is the 4 kilo is the priority, and then this is the MAC address of this switch, and then the times. Of course, the hello is the BPDU send every 2 seconds, and the maximum age is 20 seconds. Forward delay is 15 seconds, and the maximum hop, okay, it's 20. Okay, and then after calculation, who is the root of this network? This is the root of this network. Okay, of course, this BRD, just the BRD of itself. So the switch A itself is the root bridge of this network. Okay, of course, there's some many other informations, and of course, this is not the all information. The next page is on here. Okay, the next page. The STP also will list all the port, all the interface that are running STP. The state of this interface, for example, G001. G001 is forwarding. Okay, and then the port protocol and the port lower, this is a designated port. Okay, and the port cost then following the .1T standard, and the configured cost is 2000, and the active cost is 2000, and so on. And the protection type, this interface is configured root protection. Okay, and then after this, we have finished the STP protocol, and then there's 2 questions. In the event that a root bridge temporarily fails in the STP network, then another switch will take as a root bridge. Then what will happen once the failed root bridge come back? Okay, when the failed root bridge come back, then this root bridge will detect that's the network, that's the switches that have take the root bridge, sending out a BPDU. And this BPDU is not better than itself. Okay, so the comeback root bridge, okay, the switch A, for example, the switch A is the root bridge, and then the switch B is another switch. And then when this switch A is failed, then the switch B will take the root bridge lower. Okay, then the SA will come back. After switch A come back, the switch B is a root bridge, so switch B sending out BPDU. Then the switch A will know there's a switch B, and the switch B is the root bridge. But the switch A will get this information and then compare the BPDU with itself. If the switch A will know the switch B is not better than itself, so the switch A will come back as the root bridge and then sending out BPDU. And then switch B receives this BPDU and then knows that switch A is better than itself. So switch B will not work as the root bridge again, and then we'll stop sending out a BPDU. Okay, just receiving a BPDU from the switch A. Okay, this is the first question. Okay, the second question: what is the difference between pass cost and the root pass cost? Okay, the root pass cost. The pass cost is the cost of one link. Okay, and the root pass cost is the pass cost from itself, from the switch itself, along all the paths toward the root. Okay, this is a root path. Root path is a summary of all the links, summary cost of all the links, and the path cost is the cost of one link. Okay, that's the two answer of the two questions. Okay, and then we get to the end of this chapter. Thanks for you to join my presentation. Goodbye.